In this video, I wanted to discuss a few different types of addition questions that students in grade 5 are expected to work with. So the first three are really closely linked. If you look at my previous post on different types of questions, there's kind of a pre-algebra chat there from grade 4. But here we're really transitioning from shapes and pictures and suns and moons and apples and all that stuff to letters. So working with addition expressions and equations that deal with algebra. So the first one would be the most simple example, I guess, where students are asked to simplify algebraic expressions. So in this case, if e is equal to 43, then the question is just 28 plus 43. So I can do 28 plus 40, which is 68, and 68 plus 3, which has a sum of 71. So in the second example question, or in the second deck of cards, here students are expected to apply what they know from the first type of question to finding the perimeter of the rectangle. Now, some students will get kind of overwhelmed or try and do everything here mentally and get kind of lost in the steps. I really encouraged them to work at it step by step and kind of make the question a little bit easier. So the first thing to realize is that if C is equal to 16, then the dimension of my second side, which is 16 plus 14, is 30. So now we have a rectangle that has dimensions of 70 and 30, and students should be able to work with this quite easily. So we'll chop this in half like we did in the video in the previous post, and we'll find the side lengths of these two sides. So the sum of 70 and 30 is 100. And because the other half of the rectangle will have the same perimeter, so in this case the yellow line will also have a length of 100. Students can do 100 plus 100, but I'm really encouraging them to see this as 100 times 2, which is 200. And in the last question, students are just exposed to kind of an algebraic system. So they have to remember here that a in the first equation will have the same value as a in the second equation and the third equation, and so on and so forth. So with the first equation, if we solve the first equation, a plus 8 is equal to 40. We'll get a value of 32 for a. And then this, in turn, will help us solve the second equation. So if I replace a in the second equation with 32, I get 32 plus b, which is equal to 62. And in this case, the difference between 32 and 62 is 30. So the variable b has a value of 30. And then in a third equation, I can go and replace b and c. So I have c plus b, which is 30, plus a, which is 32, has a sum of 81. And that'll give me a value of c of 19. So moving on to our last type of question is where students have to compare two sums. So here they're comparing numbers, but the numbers are represented as a sum of their parts. So the biggest difficulty here is that students will confuse the symbols. So the less than symbol, greater than, and equal to. So students at this point are very comfortable with equal to. For the other two symbols, the old way that I learned, where the greater than and less than symbols were crocodiles looking to eat the side with the largest sum, seems to still work. So in this case, students will often just find the sum of both sides. So 28 plus 35 has a sum of 63. 45 and 17 have a sum of 62. So in this case, the left-hand side is greater than the right-hand side. Thanks for watching.